All right, 9. So we're on to today's lesson, question number 6. So a tennis ball has a radius of 3.4 centimeters, and this pattern is used to create the surface of one tennis ball. So this is the pattern right here. And how much material will be left over to the nearest tenth of a centimeter? So if you look at the pattern, it's going to cut all of this out, and when it puts it all together, it's going to make a tennis ball. Now, I don't have a tennis ball. So what you're really lucky in my fridge I do have is a beat. So think of the fact that your tennis ball, it's kind of an ugly beat, is going to be a circular or a sphere shape like this, where this pattern here is what is going to be joined together to make this. Okay, so that is the surface area of the tennis ball. So that part is going to be fairly straightforward to figure out. And then this is the part that's going to be a little bit more confusing. Okay, so if we take, so first let's calculate the surface area of the tennis ball. So we know that the surface area, I'm just going to call it TB for tennis ball, is going to be 4 pi r squared. And luckily for us, we know what the radius is, so this question becomes fairly straightforward at this point, times 3.4 squared. And so I can go ahead and type that into my calculator. So I have 4 times pi times 3.4 squared, and I get 145.27. So it's approximately equal to 145.27 centimeters squared. So then I need the surface area of like I need the area of the rectangle. So the area of the rectangle minus the surface area of my sphere is going to give me the part that's missing, right? So in order to find the area of the rectangle, I need to think about what's going on with my sphere. So if I took my lovely beat, I apologize, it's really scabby looking, and I peeled off from here to here, right? So I just took peels in sections and I put them all across. Then I would start peeling from here and just keep peeling and peeling and peeling until I got back to the beginning again. So this length down here, and then I'd just drop all the peels on. So this length down here would be the circumference of my sphere, or the circumference of the circle that makes up my sphere. So if you think right here, we have a sphere, right? And then typically they're kind of hard to draw, but they look like this. So this would be the circumference, right? So all you need to know is the radius of your sphere, and you can figure out your circumference. Well, the circumference of a circle, the formula for that is just 2 pi r. So this length is going to be 2 pi r. So then we need to figure out the width. Well, if you again think of your lovely sphere and you peel off a piece from here to here, then we have done half of the circumference of the beat or the tennis ball. So as soon as I peel from here to here, that's what I would drop down here. Then I would go here, peel another piece and drop down here. So this is going to be half of the circumference. So half of the circumference is just going to be pi r. So then the area of the rectangle is going to equal to 2 pi r times pi r, which is equal to 2 pi squared r squared. So I can go ahead and replace r with 3.4 squared. So if I plug that into my calculator, I have 2 times pi squared times 3.4 squared, and I get 228.19. So that is approximately equal to 228.19. Well, now I know that the area, so I know that the area of the, let's do material left over, is going to equal the area of the rectangle minus the area of the pattern, and the area of the pattern in this case is equal to the surface area of the sphere. So the surface area of the tennis ball. So that's going to equal 228.19 minus 145.27. So 228.19, whoops, let me retype that. There we go, that's better. Minus 145.27 gives us 82.92 or 82.9 centimeters squared. Hope that helps and you weren't too traumatized by my beat.